Okay, let's look at question 6. A section of a curved uh, cable that hangs between two towers of a suspension bridge can be modeled by the quadratic function. Okay, what is a quadratic function? Right? So a quadratic function can look in three ways. Y equals to ax squared plus bx plus c. Okay, or it can look like ax minus h squared plus k, or it can look like a bracket x minus p x minus q. Okay, so this is called the general form. Okay, usually question will give us in this form. Now this is called a vertex form. Okay, or usually we know it as a completed square form, right? And then this is our factorized form. Okay, now what is a factorized form? Okay, and how can we get a factorized form? Okay, imagine that we have a coordinate, we have a graph that gives us something like this, and then say, for example, this passes through 3, 5, and maybe 11, right? I don't know, maybe whatever it is. Okay, so now how to get to the factorized form? We'll say that, oh, y must be equals to a bracket x minus 3, x minus 5. Okay, because of the two intersection with the x-intercept down here. Okay, we know that when we solve for it, x must be equals to 3, x must be equals to 5. Okay, when we equate y equals to 0. Okay, now then in order to solve for the value of a, we need to sub in when x equals to 0, y equals to 11. Okay, then we'll be able to sub in and solve for the value of a. Okay, so this is what we call a factorized form. Now, then the vertex form, right? This tells us, okay, the h value and the k value, okay, determines the vertex or the turning point, right? Okay, we know that. Okay, so now this question is sort of a reverse kind of question, okay, whereby the graph down here gives us this as the y-axis and this as the x-axis. Okay, now in the model, x is the horizontal distance from the left tower to the right, or from the left tower, right? And y is the height of the cable above the road. Okay, so this is the cable, right? This one is the cable. Okay, now the cable touches the surface of the road halfway between the two towers, so over here, right? So you can notice that this is actually our turning point, okay, of the graph. So this turning point is the middle of these 2 points of 120 meters, which means that down here this must be equals to 60 and 0. Okay, so if the turning point is 60 and 0, we actually got our the turning point, which means that, which is also the vertex, which means that we completed 2 out of 3 of the unknowns in our vertex form. Okay, so we completed 2 out of 3 of the values down here already. Okay, so that means, okay, y equals to x minus 60 square plus 0. Okay, because the 60 and the 0 is the turning point. Okay, so plus 0, we don't really need to write 0 lah, huh? Okay, so there's still a a down here. Sorry, I forgot to write the a. Okay, because we don't know what is the multiplier to the curve. Okay, x minus 60 squared plus 0. Okay, but we can make use of this point, right? This point is 0 and 20. Okay, so when x equals 0, y equals 20. So 20 equals to a x minus 60 squared. A equals to 20 over 0 minus 60 square, which is equals to 1 over 180. Okay, therefore y equals to 1 over 180 x minus 60 squared. Okay, find the height of the cable along the roadway that is 20 meters away from the left tower. So 20 meters away is probably something like that. Okay, I don't know, right? So 20 meters. What is the corresponding height? Okay, they're asking for this value down here. Okay, so this one is a basic substitution question only, right? B from our equation. Y equals to 1 over 180 x minus 60 squared. When x equals to 20, y equals to 1 over 180, 20 minus 60 squared. So that is equals to 1600 over 180, which works out to be 8 whole 89 meters.